Good morning. This lesson is from our Trig-Precalc class, but before I get started, I want to say I hope everyone is doing all right out there. I don't know what lesson this is. This could be Chapter 5, Lesson 8. I don't know. I'll title it correctly in the title. But what I do know are our goals, and we have two goals. Our first goal is going to be an explanation of what solving trig equations is or are. Gosh, my grammar's terrible. And the second will be examples solving a trig equation. So let's go ahead and jump into our first goal and just ignore how bad I am at grammar. There's a reason why I don't teach math. So our first goal for this lesson, we're going to solve simple trig equations. We will only be dealing with sine and cosine functions. I think I did well with that grammar. You'll be told where on the unit circle the solutions can be found. So before we start solving equations, I want to talk about what we would call the domain of the solution. All right? And so right here, if I tell you that the solutions can be found from 0 degrees to 90 degrees, theta lies somewhere in between there, that means that my answer can include 0 degrees because I have the less than or equal to, and it can go all the way up, but not include 90 degrees. So this is what it would look like on a restricted domain or restricted solution, okay? I could also restrict it like so. 180 degrees less than theta to about 270 degrees. So we would be looking for solutions not at 180 degrees, not at 270 degrees, but at any point in between. So the solutions have to lie in there. I could also talk about radians, right? Instead of the angle measures finding locations on the unit circle, I can also talk about finding the length on the unit circle. So here I can say that I start at a length of 0 and I go to a length of 2 pi, which is all the way around the circle. So since it's open at 0, we start here, we go all the way around, and it's actually closed at 2 pi. So the answers can be anywhere on the circle. All right, so I needed to first talk about how we restrict where solutions can be. I'm going to come back and talk about solving what it means to actually solve a trig function, and then from there we'll do the example. So let me erase everything and I'll be back. I'm back. Let's go ahead and finish our first goal here. And so I want to explain what we're actually doing with this. So I've restricted where the answers can be, and I have a little equation. And so let me translate this equation. This equation is saying at what angle is the x-coordinate 1/2? Right, so it translates to at what angle theta is the x-coordinate 1/2. That's literally what this equation is saying. But remember, I restricted where that could happen. I restricted it right here. And so if we remember on our unit circle, there's only one angle that cosine or the x-coordinate can be 1/2 between 0 and 90 degrees, and it's at 60 degrees. So the answer to this equation would be the angle is 60 degrees. Okay. Now, I have a second goal, which I'd like to just kind of work through and show you a little bit more about this. But actually, let me jump right back here. Again, I know here at 60 degrees, my ordered pair is 1/2, comma, square root of 3/2. I'm interested in my x-coordinate, and I'm restricted from 0 to 90 degrees. All right. On the second problem, I am not restricted anywhere on the circle. I can go all the way around. And the second problem is asking, at what angle measurement is my x-coordinate square root of 3/2 around the entire circle? Now, this happens in 2 locations. It happens at 30 degrees, square root of 3/2, on 1/2. And it also happens at 270 degrees, square root of 3/2, comma, negative 1/2. So this answer has, or this equation has multiple answers. And it has multiple answers because this is not restricted, right? So anywhere on the circle that the x-coordinate is square root of 3 over 2, that is a solution. So theta in this instance is two answers. It's 30 degrees and it's 270 degrees. Okay? And again, that has to do with this restriction. Okay? If I would have said 180 to 360, I would have to throw that out. So hopefully that makes a little sense. Here I have sine of theta plus 1 equals a half. Now, you have to isolate the trig function. So isolate the trig function. And it's a really easy trig function to isolate. So I'll minus 1 to both sides. If I owe $1, I give you 50 cents. You're going to tell me I owe you 50 cents. So what this equation is asking is, what is the y-coordinate from 0 to 300, or what is the angle that gives me the y-coordinate from 0 to 360 degrees? That's negative 1/2. So, oh, I got one right here. So 270 would be a solution, as well as 210 degrees. Because at 210 degrees, my ordered pair is negative square root of 3 over 2, comma, negative 1/2. So this equation, we had to isolate the trig function, and we find out what angle measures give me a y-coordinate of negative 1/2. Remember, translate these things. So in this equation, theta is going to be equal to 210 degrees and 270 degrees. So hopefully this makes some sense to you, solving simple trig functions. We will get into more complicated ones, but I just wanted to start off with the simple ones. Hopefully this makes sense. I keep repeating myself. Alright, so I'm going to go ahead and end the video here. Again, I hope everyone is doing alright out there. Have a good day, everybody. Bye-bye.